Okay, Newton's second law says F equals ma. Force equals mass times acceleration. Okay, so if you want to generally understand the forces that we're talking about when these plates slip by each other and release this energy, right? That energy released is a calculation of mass times acceleration. We already know generally that the acceleration can be anywhere between 0.6 centimeters a year or up to 10 centimeters a year, which when we start talking about meters per second, it's a very, very, very small number, okay? So your acceleration is extremely, extremely small, okay? And then you have mass. The mass of these tectonic plates is humongous, so large. For example, the size of the North American tectonic plate is 75,900,000 kilometers squared. Absolutely huge, okay? And that's not even the mass, that's just surface area, okay? So imagine the mass associated with that. So your mass of the plate is ginormous, right? Times a little tiny bit of acceleration, right? And somewhere between the math, the number works out to a fairly large force. The reason why that force is so large is simply the sheer size of that number for mass, right? The sheer mass of the plate produces a relatively large force. If these plates were moving any faster, the force would be astronomical, right? Because now you have a really big number times a decently big number, right? And now it's just an absurd amount of force.